Thousands of years before satellites or star charts, our ancestors gazed up at the same night sky we see today, only they saw something far more profound. Without computers or compasses, prehistoric cultures decoded celestial mysteries with nothing but observation, intuition, and stone. Think about that for a moment. Monuments like Stonehenge weren't just sacred sites, they were ancient observatories, meticulously aligned with solstices and eclipses. The pyramids of Egypt, their corridors point directly to key stars, acting as eternal guides to the heavens. How did civilizations separated by oceans and millennia share such precise astronomical knowledge? What secrets did they bury in these stone blueprints of the cosmos? In this video, we're peeling back layers of time to reveal how prehistoric skywatchers turned myths into maps and darkness into understanding. Their legacy isn't just carved in rock, it's written in the very stars above us. Picture a world without streetlights, without glowing screens, just the vast, unbroken darkness of night, pierced by countless stars. That was the canvas our ancestors studied with unwavering focus. From the earliest hunters to the first farmers, humans looked up and saw more than just scattered points of light. They noticed patterns, the way certain stars appeared only in winter, or how the moon's phases marked the passing weeks. These weren't casual observations, they were lifelines. Take the famous Lascaux cave paintings in France, created over 17,000 years ago. Among images of bison and deer, you'll find dots and shapes that many researchers believe represent the Pleiades star cluster. On the other side of the world, Aboriginal Australians mapped the sky through songlines, oral traditions that linked constellations to stories and sacred routes across the land. The sky wasn't just above them, it was part of their identity, their survival. But why did so many cultures, separated by vast distances, share this obsession with the stars? The answer lies in necessity. The rising of Sirius signaled the annual flooding of the Nile, crucial for Egypt's crops. In the Americas, the position of the sun marked planting seasons. Even the simplest observation, like tracking the North Star, could mean the difference between finding home or becoming forever lost. And then there's the spiritual side. Many ancient societies saw the heavens as the realm of gods and ancestors. The movement of celestial bodies wasn't just physics, it was divine communication. From the Babylonian priests who recorded eclipses as omens to the Mayans who built temples aligned with Venus, the sky was both a tool and a temple. So next time you glance upward on a clear night, remember you're seeing what our ancestors saw, the same stars that guided them, fed them, and connected them to something greater. And that's a legacy written in light. Standing silently on England's Salisbury Plain, Stonehenge has defied centuries of speculation, its towering stones whispering secrets of a lost astronomical art. What's astonishing isn't just its age, over 5,000 years old, but the fact that its creators, armed with no more than ropes and rudimentary tools, engineered alignments so precise they still mark the sun's movements to this day. At dawn on the summer solstice, sunlight slices through the monument's heart, striking the heel stone with pinpoint accuracy. Lunar eclipses, the gaps between stones frame them like celestial bookmarks. This wasn't haphazard construction, it was deliberate, calculated genius, but here's where the mystery deepens. Unlike later civilizations with written records, the builders left no manuals, only clues in the architecture itself. Some researchers argue Stonehenge doubled as a sacred cemetery. Its blue stones hauled hundreds of miles from Wales, perhaps for their rumored healing properties. Others see it as a grand celestial calendar, tracking seasons to guide planting and harvests. Then there's the ritual angle. Could the solstice alignment have been a bridge between the living and the spirits, a moment when the veil between worlds grew thin? What's undeniable is the sophistication behind the design. The outer ring's lintels curve slightly to account for Earth's curvature, ensuring seamless alignment. Even the spacing of the stones reflects an understanding of lunar cycles, with certain gaps corresponding to eclipses that repeat every 18.6 years. How did a Neolithic culture, without mathematics as we know it, decode these patterns? Some theorize generations of skywatchers passed down knowledge orally, refining it over centuries. Stonehenge forces us to rethink what primitive really means. These weren't just farmers piling rocks, they were astronomers, architects, and philosophers mapping time itself in stone. And perhaps that's the most humbling lesson of all. Long before telescopes or textbooks, humanity had already begun its timeless conversation with the stars. Buried for millennia in a German forest, the Nebra Skydisk is one of archaeology's most astonishing finds, a shimmering bronze portal into the minds of Bronze Age skywatchers. Unearthed by treasure hunters in 1999, this 3,600-year-old artifact isn't just art. It's a snapshot of the cosmos frozen in metal. The disk's surface gleams with gold symbols, a crescent moon, a full sun, and a cluster of stars believed to be the Pleiades, all arranged with deliberate precision. Even more striking are the arcs along its edges, two marking the solstices and one that might depict a sacred barge, carrying the sun across the night sky according to ancient myth. What makes this object so revolutionary is its dual nature. Unlike stationary monuments like Stonehenge, the Nebra Skydisk was portable, a handheld observatory that could have been used to teach, to predict celestial events, or even to synchronize lunar and solar calendars. Imagine a Bronze Age priest or elder holding it aloft, aligning its gold inlays with the real stars above, turning myth into measurable time. The disk's creators didn't just observe the heavens, they encoded them, blending astronomy with spirituality in a way that feels both alien and eerily familiar. Yet the mystery lingers. How did they achieve such accuracy? The disk's makers lacked writing, let alone precise instruments, yet their understanding of the 18.6-year lunar cycle rivals later Greek astronomers. Some scholars argue the disk was a tool for farmers, marking planting seasons. Others see it as a ritual object, its gold symbols acting as a bridge to the divine. And then there's the tantalizing possibility it was used for navigation, a celestial map for traders or travelers moving across Europe's ancient landscapes. The Nebra Skydisk shatters stereotypes of prehistoric Europe as a backwater. Here was a culture advanced enough to alloy metals, track complex astronomical patterns, and fuse science with symbol. It's a reminder that curiosity about the cosmos isn't a modern trait. It's as old as humanity itself, and perhaps that's the disk's greatest lesson. Even in the Bronze Age, the stars weren't just lights in the sky. They were a language waiting to be read. The Great Pyramid of Giza stands not just as a tomb for pharaohs, but as a towering testament to humanity's first attempts to touch the stars. Its precision is staggering. The base aligns almost perfectly with the cardinal directions north, south, east, and west, with an error margin smaller than a fraction of a degree. How did a civilization without modern tools achieve such accuracy? The answer lies in the stars themselves. The three pyramids of Giza mirror the three stars of Orion's belt, a constellation the Egyptians linked to Osiris, god of the afterlife. For them, the cosmos wasn't just a backdrop, it was a roadmap to eternity, but the celestial connections run deeper. The narrow shafts inside the Great Pyramid don't just vent air, they point directly to key stars. One aligns with the North Star, anchoring the pyramid to the heavens, while another targets Sirius, the brightest star in the sky. To the Egyptians, Sirius wasn't just a light in the darkness. Its annual rising coincided with the Nile's life-giving flood, a cycle so vital it shaped their entire calendar. Temples like Karnak were designed to capture the sun's rays on specific dates, illuminating inner sanctuaries like divine spotlights. Even obelisks functioned as giant sundials, casting shadows that marked sacred time. What's often overlooked is how much they documented. Hieroglyphs and papyri reveal detailed star charts and planetary records. The Cairo calendar, for instance, tracks favorable and unfavorable days based on celestial events, blending astronomy with daily life. The Egyptians didn't merely observe the skies, they integrated them into architecture, religion, and even agriculture. The pyramids, then, were more than stone and mortar. They were stairways for the pharaoh's soul to ascend, cosmic elevators bridging Earth and the realm of the gods. So when we marvel at these ancient wonders, we're not just seeing tombs. We're witnessing humanity's earliest obsession with the cosmos, an obsession that turned stone into stars and death into a journey home. Centuries before telescopes or planetariums, Babylon's scholars crouched over damp clay by flickering torchlight, etching the heavens into permanence. These weren't just notes, they were the first known star catalogues, meticulous records of planetary movements, eclipses, and constellations, preserved on tablets that survived empires. What's remarkable isn't just their precision, but their purpose. To the Babylonians, the stars weren't merely lights. They were messages. A comet might warn of invasion. Jupiter's position could predict harvest. Every celestial event held meaning, and their priests astronomers became the codebreakers of the cosmos. Among their breakthroughs was the division of the sky into 12 equal slices, a system so enduring it became the zodiac we recognize today. Unlike earlier cultures that grouped stars loosely by myth, the Babylonians mapped them mathematically, assigning precise dates to each sector. Their calculations weren't guesses, they were based on decades of nightly observations, tracked with astonishing accuracy. Take the Venus tablet of Amasajuka, detailing the planet's movements over 21 years. Modern astronomers have verified its data, finding discrepancies of mere days across millennia. But here's where their legacy truly shines. These stargazers didn't just observe, they predicted. Using cyclical patterns, they forecast lunar eclipses down to the hour, a feat that required understanding the Saros cycle, a repeating 18-year pattern of alignment between Earth, Moon, and Sun. Their math-heavy approach laid groundwork for later Greek astronomers like Ptolemy, and even Islamic scholars who refined their tables. Yet for all their science, astrology and astronomy were inseparable. A planet's path might dictate a king's decision or the timing of a temple ritual. What's often overlooked is the sheer scale of their ambition, the mul. Pinned tablets among the oldest surviving catalogues don't just list stars. They chart rising and setting times, create seasonal calendars, and even include farming advice tied to celestial events. Imagine a civilization where studying the sky was as practical as checking the weather app today. The Babylonians remind us that science and spirituality once walked hand in hand. Their star catalogues weren't cold data, they were a bridge between Earth and sky where mathematics met mystery. And in that balance, they gifted humanity something timeless, the map to our own place in the universe. Deep in the jungles of Central America, where howler monkeys and tropical birds fill the air, the Maya crafted a celestial science so precise it rivals modern astronomy. At the heart of their cosmic obsession stood El Caracol, an observatory shaped like a spiraling snail shell, its narrow windows perfectly framing the movements of Venus. To the Maya, Venus wasn't just a bright dot in the sky, it was Kukulkan, the feathered serpent god whose appearances dictated the timing of wars, coronations, and even sacrifices. Their long count calendar is where their brilliance truly shines. Unlike simple lunar cycles, this system tracked time across millennia, calculating planetary alignments down to the minute. When modern scientists compared Mayan eclipse predictions to historical records, The margin of error was less than a single day over a span of 500 years. How did they achieve such accuracy without telescopes or metal tools? The answer lies in generations of unbroken observation. Mayan astronomers meticulously recorded celestial events in bark paper codices, noting patterns invisible to the untrained eye. But their astronomy wasn't just about math, it was a dialogue with the divine. Temples like Tikul's Temple Roman IV were built to align with solstices, casting serpent-shaped shadows during equinoxes. Even their ball courts held astronomical significance. The movement of the sun during games mirrored the journey of the gods through the underworld. What's often overlooked is how deeply astronomy permeated daily life. Farmers planted crops according to Venus's cycles, while traders timed voyages by the stars. Glyphs on stelae didn't just commemorate kings, they immortalized celestial events, binding human history to the cosmos. The Maya remind us that science and spirit weren't opposing forces, they were two sides of the same obsidian mirror. In their world, the sky wasn't just studied, it was lived. And perhaps that's the most profound lesson of all. Their legacy isn't just etched in stone, but in the very rhythm of the stars they revered. High in the Andes, where the thin air makes the stars burn brighter, the Incas spun the Milky Way into the very fabric of their world. Unlike other cultures that saw it as a path or bridge, they called it Mayu, a shimmering celestial river flowing through the night, its currents alive with constellations they didn't just name but felt. To them, the stars weren't distant dots but living creatures, a llama, a serpent, even a shepherd tending his flock, all woven into myths that guided everything from harvests to empire building. Cusco, their capital, wasn't just a city, it was a mirror of the heavens. Its temples and plazas aligned with the solstices, while sacred pathways traced the Milky Way's arc across the earth. But the real genius lay in the sucancas, stone pillars placed on mountain ridges. These weren't mere markers, they functioned like a giant sundial. As the sun rose between specific pillars during equinoxes, priests could predict planting seasons with pinpoint accuracy. Imagine standing atop a peak at dawn, watching sunlight slice between stones to signal when to sow potatoes or quinoa, an entire agricultural calendar etched into the landscape. What's striking is how seamlessly they fused astronomy with survival. The Pleiades, known as Quilca storehouse, weren't just pretty stars, their brightness at dawn predicted rainfall. A dim appearance meant drought, prompting farmers to delay planting. Even their roads, stretching thousands of miles, followed celestial alignments, turning the empire itself into a living map of the cosmos. And then there's the spiritual layer. The Incas believed the Milky Way's dark clouds, those dust lanes we barely notice, were celestial animals drinking from the river, their shadows shaping destinies below. Every eclipse, every comet was a conversation between realms, a reminder that the sky and earth were partners, not strangers. So while they left no grand observatories like Stonehenge or pyramids, their legacy is just as profound. The Incas didn't just study the stars, they lived beneath them, turning the heavens into a guide, a clock, and a story written light years long. And in that story, we see a truth still relevant today. The universe isn't something to conquer. It's a companion whispering secrets to those willing to look up. Long before telescopes or satellites, imperial astronomers in ancient China stood watch on moonlit terraces, charting the heavens with astonishing precision. Their observations weren't just scientific curiosity, they were matters of life and death. The Chinese believed the cosmos held the mandate of heaven, a divine approval system where celestial events could bless or doom an emperor's reign. A single comet might signal rebellion, a supernova could herald the fall of a dynasty. This wasn't casual stargazing, it was a highly organized science. The sky was divided into 28 zhu or lunar mansions, each tied to specific constellations and seasons. These weren't arbitrary divisions, they formed a celestial clockwork guiding everything from agriculture to warfare. The Dunhuang Star Atlas, painted on paper around the year 700, remains the oldest complete star map ever found. Its delicate brushstrokes map over 1,300 stars with surprising accuracy, grouping them into constellations shaped like palaces, marketplaces, and even imperial chariots. But what's truly fascinating is how these records blurred the line between astronomy and statecraft. Emperors employed court astronomers not just to predict eclipses, but to read the sky for omens. Sunspots, recorded as early as 28 BC, were seen as celestial warnings, dark blemishes on the sun's face signaling earthly unrest. When a guest star, likely a supernova, erupted in the year 1054, it was meticulously documented alongside political upheavals, as if the heavens themselves were annotating history. Yet for all its spiritual weight, Chinese astronomy was also ruthlessly practical. Star charts were guarded like state secrets, their knowledge reserved for elites who believed controlling the skies meant controlling fate itself. Observatories like the one in ancient Beijing weren't just research centers, they were power tools, ensuring the emperor's grip on both earth and heaven. In the end, these star charts reveal a civilization that saw no separation between science and sovereignty. To the Chinese court, the night sky wasn't just a spectacle, it was the ultimate imperial ledger, where every flicker of light held a message and every silence spoke volumes. And perhaps that's the most striking legacy of all, a system where the stars didn't just guide ships or seasons, they steered empires. While ancient cultures sought meaning in the stars through myth and ritual, the Greeks took a revolutionary step. They turned the heavens into a geometric puzzle. Picture scholars debating under olive trees, not about gods shaping fate, but about angles, spheres, and the precise mechanics of the cosmos. Pythagoras, better known for his theorem, was among the first to propose Earth wasn't flat, but a perfect sphere suspended in space. Then came Aristarchus of Samos, who dared suggest something even more radical, that Earth orbited the Sun, an idea so ahead of its time it wouldn't be proven for another 18 centuries. But the crown jewel of Greek astronomical genius isn't a theory, it's a corroded bronze artifact pulled from a shipwreck off Antikythera in 1901. At first glance, it looked like junk. Then researchers realized its gears formed an intricate analog computer, capable of predicting eclipses and planetary movements with eerie precision. Designed around 80 BC, the Antikythera mechanism didn't just track time. It modeled the cosmos, its dials mirroring the dance of the moon, sun, and 5 known planets. This wasn't mere stargazing, it was celestial engineering. What set the Greeks apart wasn't just their tools, but their mindset. They blended Babylonian star catalogues with their own philosophical rigor, asking not just how the heavens moved, but why. Hipparchus mapped over 850 stars, noticing Earth's wobble precession long before telescopes. Ptolemy's Almagest, though later proven flawed, systematized planetary motion into a model so convincing it dominated astronomy for 1400 years. Yet for all their logic, the Greeks never fully abandoned wonder. Constellations remained tied to myth. Orion the Hunter still strode across their star charts. The difference, now his belt stars had coordinates, his movements calculable. In merging poetry with precision, the Greeks gave us more than theories. They handed us the first true language of the stars, one where equations and epics could share the same sky. Forget GPS or compasses, imagine crossing thousands of miles of open ocean with nothing but the stars as your guide. This wasn't just possible for Polynesian navigators, it was routine. With no written records or instruments, they mastered the Pacific's endless blue, not by luck, but by turning the night sky into a living map. Their secret, a star compass not carved in wood or stone, but passed down through chants and stories memorized with flawless precision. Each star held meaning. As it rose or set over the horizon, it became a fixed reference point like a celestial lighthouse. Navigators knew that when the Pleiades appeared at a certain angle, they were near Tahiti. When Sirius stood high, it signaled the path to Hawaii, but stars alone weren't enough. They read the ocean itself, the way swells bent around islands, the flight patterns of birds, even the subtle shifts in watercolor. A ripple could mean land was near, a change in wind carried clues. What's astonishing isn't just their accuracy, but their endurance. Voyages like the 3,500-mile journey from Tahiti to Hawaii weren't one-offs. They were part of a vast network of trade and migration, all achieved centuries before European explorers dared sail beyond sight of shore. And while Western sailors relied on sextants and charts, Polynesians trusted something deeper, tradition. Elders taught the next generation through song, encoding navigation secrets in melodies that survived generations. This wasn't just science, it was art. A navigator would lie in the hull, feeling the canoe's movement, listening to the waves and watching the stars, synthesizing it all into a mental map. No room for error. One mistake meant vanishing into the abyss. Yet they thrived, settling islands scattered across an area twice the size of Russia. Today, this ancient wisdom isn't lost. Modern Hawaiian navigators like Nainoa Thompson still use these methods, proving that the stars haven't forgotten their old paths. And perhaps that's the most humbling lesson, that long before satellites, humanity's greatest voyages weren't powered by technology, but by something far more profound, the courage to look up and trust the sky. Under the vast skies of North America, where prairies meet mountains, Native American tribes didn't just watch the stars. They wove them into the very fabric of their existence. For the Lakota, the night sky wasn't a distant mystery, it was a sacred storybook. The 7 bright stars of the Pleiades, they called them Wisinkola Sakauin, the 7 little girls, fleeing across the heavens to escape earthly danger. To the Navajo, the constellation we know as Orion was Atsi-Atsusiai, the first big one, whose belt stars guided winter ceremonies. These weren't mere myths, they were sophisticated teaching tools, encoding survival knowledge in celestial patterns passed down through generations. One of the most striking examples still stands in Wyoming's Bighorn Mountains. The Medicine Wheel, a stone circle with 28 spokes radiating outward, isn't just a spiritual sight, it's a precision-built astronomical calendar. At dawn on the summer solstice, sunlight pierces gaps in the surrounding cairns, aligning perfectly with the wheel's central stone. Other sightlines point to key stars like Sirius and Aldebaran, marking seasonal shifts critical for hunting and planting. What's remarkable isn't just its accuracy, but its endurance. Built over 7 centuries ago, it still functions today as both an observatory and a living classroom. This celestial wisdom served urgent practical needs. The Pawnee timed their buffalo hunts by tracking the position of the corona borealis, while the Zuni used the orientation of certain stars to determine when to plant corn. But the stars' role went deeper than agriculture. The Skidi Pawnee performed the morning star ritual, closely tied to Venus's appearance, believing it ensured cosmic balance. The Hopi, meanwhile, saw the Milky Way as the road souls traveled after death, a shimmering pathway between worlds. Modern astronomy often dismisses these traditions as folklore, yet they reveal something profound. These cultures didn't separate science from spirituality. When a Navajo elder points to Cassiopeia and calls it Nash Jayai as our Spider-Woman, she's not just naming a constellation. She's preserving a complex understanding of seasonal cycles, morality tales, and the interconnectedness of all things. The night sky wasn't a cold expanse to be conquered, but a living network of relationships where every star had a story, and every story held a lesson. Perhaps that's the greatest gift of Native American astronomy. In a world obsessed with data points and light years, these traditions remind us that the stars are more than celestial objects. They're teachers, guides, and silent witnesses to humanity's deepest questions. And in their light, we see not just where we are, but who we've always been. Deep in the arid cliffs of Mali's Bandiagara escarpment, the Dogon people safeguard a celestial secret that still baffles astronomers. For generations, their oral traditions have spoken of Sirius B, a dense, invisible star orbiting Sirius, the brightest star in our sky. Here's the puzzle. Sirius B wasn't observed through telescopes until the 19th century, yet the Dogon not only knew of its existence but described its elliptical 50-year orbit and even its intense density. How some theories suggest ancient contact with advanced civilizations, while others argue for a forgotten era of indigenous astronomical brilliance. But the Dogon's knowledge wasn't isolated. Across Africa, celestial wisdom shaped daily life. The Borana people of Ethiopia and Kenya built stone observatories like the Giza system, tracking star movements to create a lunar stellar calendar still used today. In Egypt, the star Sirius's rising marked the Nile's flood, while the Tiswana of southern Africa timed their planting seasons by the Pleiades' position. What's often overlooked is the sophistication behind these systems. Without written records, African cultures encoded astronomical data in myths, dances, and architecture. The great Zimbabwe ruins, for instance, align with solstices and lunar standstills, turning stone walls into silent celestial calculators. Even navigation relied on the stars. The Swahili sailors of East Africa used constellations to guide how ships across the Indian Ocean, trading as far as China. The real mystery isn't just how the Dogon knew about Sirius B, it's why Western science took so long to recognize Africa's astronomical legacy. These traditions weren't primitive guesses, they were precise, practical, and deeply interwoven with survival. From the Sahara to the Savannah, the stars were more than lights. They were the first teachers, the original clocks, and the quiet architects of human ingenuity. And in that light, they remind us that the cosmos doesn't belong to any one culture. It speaks to all who dare to listen. From the jungles of Cambodia to the rolling hills of Ireland, ancient architects designed sacred spaces with more than just stone. They built them with the sky in mind. Angkor Wat, the world's largest religious monument, doesn't just impress with its scale. It's a masterpiece of celestial choreography. At dawn on the spring equinox, sunlight pierces the temple's central tower, illuminating inner chambers with pinpoint accuracy. But this isn't just a dramatic light show. It's a meticulously engineered calendar, marking the start of harvest season for the Khmer Empire. Jump across the globe to Newgrange in Ireland, a passage tomb older than the pyramids. During the winter solstice, sunlight creeps through a narrow roof box, flooding the inner chamber with golden light for just 17 minutes. The precision is staggering, a slit no wider than a modern doorway, aligning perfectly with the year's shortest day. Was this a tomb, a temple, or an ancient observatory? The truth might be all three. What's striking isn't just the accuracy of these alignments, it's their universality. In Egypt, the Temple of Abu Simbel was designed so that twice a year, sunlight would reach deep into its sanctuary to illuminate statues of gods. In Mexico, El Castillo at Chichen, its art transforms into a serpent of light during equinoxes, with shadows slithering down its steps like cosmic clockwork. These cultures never met, yet they all heard the same celestial rhythm. Could this be more than coincidence? Some researchers argue these alignments reveal lost networks of shared knowledge, perhaps carried by prehistoric travelers or whispered through trade routes. Others see something deeper, a fundamental human yearning to connect the earthly and the divine through the stars. Whether by design or instinct, these temples tell a story far grander than their walls. They're proof that long before textbooks or telescopes, humanity was already writing its story in the language of light. So the next time you stand beneath a towering spire or step inside an ancient corridor, look closer. The stones might not just be holding up a roof, they could be holding up a mirror to the heavens. Look up at Orion's belt tonight, and you're seeing more than just 3 bright stars. You're glimpsing a story thousands of years in the making. To the ancient Greeks, this constellation was a mighty hunter, forever chasing the Pleiades across the sky. For the indigenous Yolngu people of Australia, those same stars formed a canoe carrying fishermen through the heavens. In Egypt, they became the backbone of Osiris, god of resurrection. These weren't just imaginative tales, they were ingenious memory tools turning star patterns into unforgettable narratives. Mythology did what early textbooks couldn't. Without written records, complex astronomical knowledge had to survive through oral tradition. And what sticks in memory better than a gripping story? The Norse spoke of Skal and Hati, wolves eternally chasing the sun and moon, a poetic explanation for eclipses. Aboriginal Australians mapped the Milky Way as a river where ancestral spirits fished, its curves marking seasonal changes. Even comets and meteors found roles as celestial omens or divine messengers, their unpredictability woven into legends of chaos and transformation. What's fascinating isn't just the variety of these stories, but their shared roots. Cultures separated by oceans often personified the same clusters, like the Pleiades, depicted as 7 sisters in Greek, Japanese, and Cherokee traditions. This wasn't coincidence, it was proof that storytelling and stargazing evolved together. The stars became characters, their movements a plotline to track time, predict harvests, or warn of floods. But here's where myth transcends mere utility. These stories reveal how deeply our ancestors felt connected to the cosmos. When the Maya saw Venus as Kukulkan, or the Inuit viewed the aurora as ancestors playing ball with a walrus skull, they weren't just explaining phenomena, they were affirming a relationship with the universe. The sky wasn't cold or distant, it was alive, resonant with meaning. So the next time you hear an old myth about the stars, listen closely. Hidden between the lines isn't just fantasy, it's humanity's first attempt to make sense of the infinite, one story at a time. Beneath the vast desert skies of ancient Egypt, astronomers didn't just rely on their eyes, they crafted tools as precise as they were elegant. Take the Merkit, a simple but brilliant device made from a palm rib and a weighted string. Used in pairs, these star clocks could measure the alignment of celestial bodies with astonishing accuracy, helping priests time rituals or architects orient pyramids to true north. Imagine standing on a temple roof at night, stretching the cord taut to track Sirius's rise. This wasn't just stargazing, it was geometry in motion. Across the ocean, in what's now New Mexico, the ancestral Puebloans engineered their own celestial observatory. At Choco Canyon, a sliver of sunlight pierces through rock carvings at noon during solstices, casting a sun dagger onto spiral petroglyphs below. This wasn't random artistry, it was a solar calendar carved into stone, marking the year's turning points with knife-edge precision. How did cultures continents apart arrive at such similar innovations? Necessity and ingenuity, turning shadows and stones into cosmic clocks. Then there's the astrolabe, a handheld marvel born in ancient Greece and perfected by Islamic scholars. More than just a star map, this intricate brass device could calculate time, predict sunrise, and even determine prayer directions, all by aligning rotating disks with the night sky. Its engraved coordinates weren't mere decoration. They were a portable universe, condensing centuries of observation into a tool that fit in the palm of your hand. Yet perhaps the most overlooked innovation lies in the quadrant, a humble quarter circle of wood or metal that transformed navigation. Arab astronomers like al-Biruni refined its design, using it to measure star angles with unprecedented accuracy. These weren't just tools, they were bridges between earth and sky, between myth and math. What's striking isn't just the sophistication of these devices, but the universal drive behind them. Whether etched in rock or cast in bronze, they reveal a truth we often forget. The ancients didn't just watch the stars, they measured, calculated, and engineered their way into the cosmos, proving that curiosity, not just technology, is the true compass of discovery. So next time you check your phone's GPS, spare a thought for the Merkit's shadow or the astrolabe's gears. The sky hasn't changed, only the tools we use to read it. And in that light, we're not so different from those ancient skywatchers after all. The accuracy of ancient astronomers still sparks heated debates today. How could cultures without telescopes or calculators achieve knowledge that seems to defy their era? Take the Dogon people's understanding of Sirius B, a star so faint it wasn't officially discovered until the 19th century. Their oral traditions describe its dense, compact nature, and its 50-year orbit around Sirius are with eerie precision. Some theorists argue this points to contact with an advanced civilization, perhaps even extraterrestrial visitors who shared celestial secrets. Skeptics, though, propose a simpler explanation. Generations of meticulous observation passed down through storytelling, refined over centuries until their descriptions matched reality. Then there's the Maya, whose long count calendar predicted lunar eclipses down to the hour, centuries before modern astronomy confirmed their calculations. Could they have developed a lost technology, some kind of proto-computer, to track the heavens with such exactitude? Or was it sheer intellectual brilliance, a lifetime of watching the sky's patterns until they cracked its code? The truth might lie somewhere in between. Many scholars suggest that ancient astronomers used tools we've underestimated, like water-filled basins to reflect the stars, or aligned stone markers serving as rudimentary observatories. But here's where things get even more intriguing. Some researchers, like Dr. Anthony Aveney, point out that these so-called impossible feats often stem from Western biases, assuming ancient cultures couldn't achieve such sophistication without outside help. After all, Polynesian navigators crossed thousands of miles without compasses, and Babylonian astronomers calculated planetary motions using only clay tablets. Maybe we've been overlooking something critical: the power of human ingenuity when survival depends on reading the sky. Yet the controversies persist because they force us to confront bigger questions. Were the stars merely observed, or were some civilizations tapping into deeper, forgotten wisdom? Could myth and science have once been intertwined, pointing to truths modern astronomy is only now rediscovering? Every new archaeological find, from the Antikythera mechanism to alignments in forgotten temples, adds another layer to the mystery. One thing is certain: these debates aren't just about the past. They challenge how we define knowledge itself. Were the ancients lucky guessers, divine messengers, or simply the first scientists patiently unlocking the universe's secrets under the same stars we gaze upon today? The answer might still be written in the night sky, waiting to be decoded. Imagine standing in front of an ancient temple, watching sunlight carve a beam across worn stone floors. But this isn't just a play of light. For archaeoastronomers, it's a message from the past, a deliberate alignment meant to mark solstices, equinoxes, or celestial events. This field doesn't just study ruins or stars, it unravels the conversation between them, showing how civilizations turned mountains into calendars and temples into cosmic clocks. Take the case of Machu Picchu. At first glance, it's a marvel of Incan engineering, but look closer. The Intihuatana stone, often called the hitching post of the sun, casts no shadow at noon during the equinoxes. Nearby windows frame the June solstice sunrise with millimeter precision. For decades, these details were brushed off as ritual curiosities until archaeoastronomy proved otherwise. Using software like Stellarium, researchers simulated the sky as it appeared 5 centuries ago, confirming these weren't random placements. The Incas had engineered their sacred city to sync with the heavens down to the minute. What sets this discipline apart is its toolkit. Beyond shovels and brushes, archaeoastronomers wield laser scans, 3D modeling, and even virtual reality to reconstruct how ancient structures interacted with celestial movements. In Choco Canyon, drones mapped petroglyph alignments invisible from the ground, revealing how ancestral pueblones used sunlight to mark lunar standstills, rare events occurring only every 18 years. Yet the real revelation isn't just technical, it's philosophical. These findings challenge old assumptions that prehistoric cultures were merely primitive stargazers. When Neolithic builders hauled 20-ton stones to create Newgrange's solstice-aligned passage, they weren't just worshipping the sun, they were predicting it, blending spirituality with proto-scientific observation. The beauty of archaeoastronomy lies in its humility. It doesn't dismiss myths as fairy tales, but asks what truths might they encode. A story about a hero chasing the Pleiades could also be a farming calendar. A temple's sacred alignment might secretly track Venus's cycles. In piecing together these puzzles, we're not just decoding the past, we're rediscovering humanity's oldest classroom, where the sky was both textbook and teacher. And perhaps that's the greatest lesson of all. These ancient skywatchers didn't need modern gadgets to grasp the cosmos. They had patience, curiosity, and an unshakable belief that the stars were speaking. Our task isn't just to hear their words, but to understand the language they spoke in. Long before digital clocks or printed calendars, humanity kept time by the only reliable constant they knew, the steady dance of celestial bodies. Consider this: 5,000 years ago, a farmer in Mesopotamia wouldn't check his phone for the date. Instead, he'd watch for the first appearance of Sirius at dawn, signaling the Nile's flood was near. Time wasn't measured in minutes back then. It was etched in the stars, woven into the very fabric of survival. The Egyptians took this a step further, crafting the first solar calendar around 4000 BC. Unlike lunar cycles that drifted with the seasons, their 365-day year divided into 12 months of 30 days, plus 5 epigonal days, aligned almost perfectly with the sun's journey. But here's the genius: they didn't just track days. The rising of Sopdet Sirius marked the new year, coinciding with the Nile's life-giving floods. Astronomy wasn't just science for them, it was the rhythm of existence, synchronizing harvests, taxes, and even religious festivals with celestial events. Meanwhile, across the Atlantic, the Maya engineered a calendar system so intricate it still baffles modern scholars. Their Hob calendar mirrored the solar year with 18 months of 20 days, plus a brief, unlucky period. But the real marvel was the Tzolk'in, a 260-day sacred cycle that interlocked with the Hob like gears in a cosmic clock. Every 52 years, the two calendars realigned, marking a calendar round so significant it warranted city-wide renewal ceremonies. And then there's the long count, a linear timeline stretching back to their mythological creation date, capable of pinpointing events millennia in the future. What's striking isn't just the accuracy of these systems, but their shared purpose. Whether carved into Egyptian temple walls or encoded in Mayan codices, these calendars did more than count days. They fused time with destiny, weaving human lives into the grand tapestry of the cosmos. A solstice wasn't just a date, it was a dialogue between earth and sky, a reminder that humanity's story was never meant to be told apart from the stars. So the next time you glance at a calendar, remember, those neatly labeled squares are echoes of an ancient obsession, one that turned the heavens into history's first clock. And in that shared gaze upward, we're still keeping time with our ancestors. When you check your watch or glance at a calendar today, you're tapping into knowledge that's millennia in the making. That 60-minute hour dividing your day, it's a gift from Babylonian mathematicians who loved base 60 calculations so much they applied them to timekeeping. The zodiac constellations guiding horoscopes, they're echoes of Mesopotamian star maps from 3,000 years ago. Even the names of planets, Mars, Venus, Jupiter, carry the legacy of Roman gods who once ruled the night sky. The past isn't just history, it's the silent scaffolding holding up our modern understanding of the cosmos. Long before Galileo pointed his telescope skyward or Copernicus dared to dethrone Earth as the universe's center, ancient astronomers were quietly laying the foundations of science itself. The Greeks borrowed star catalogues from Babylon, refining them into geometry. Islamic scholars preserved and expanded these texts during Europe's Middle Ages, adding precise planetary models. By the time Renaissance thinkers rediscovered these works, they weren't starting from scratch, they were standing on the shoulders of giants who'd spent centuries watching, recording, and questioning. Yet there's something deeper here than just historical influence. Ancient stargazers didn't just chart stars, they taught us how to think empirically. When Mayan priests predicted eclipses or Polynesian navigators memorized star paths, they were using the same fundamental principles that guide modern astrophysics: observation, pattern recognition, and prediction. The tools have changed, but the curiosity that drives us hasn't. Perhaps the most profound lesson these skywatchers left isn't in their charts or monuments, it's in their perspective. For them, the cosmos wasn't a distant abstraction, but a living, breathing presence. The Inca saw the Milky Way as a celestial river. Norse myths turned auroras into warriors' armor. While we've gained incredible precision since then, we've also lost something, that visceral connection between the heavens and daily life. Now, as we peer through telescopes at exoplanets or simulate galaxies on supercomputers, we're completing a circle those first astronomers began. Their legacy isn't confined to museums. It's written in every modern discovery, a reminder that the urge to explore the stars is as old as humanity itself. And in an age of light pollution and digital distractions, maybe their greatest gift is this invitation: to look up again with both the rigor of science and the wonder of our ancestors. Hidden beneath dense jungle canopies and buried within forgotten caves, ancient astronomical knowledge is resurfacing in ways that would astonish even the scholars of past centuries. Modern technology like LiDAR laser scanning from aircraft has peeled back layers of earth and vegetation to expose startling celestial alignments at sites once thought fully understood. In Cambodia, Angkor Wat's hidden corridors now reveal precise solstice markers invisible to the naked eye. Over in Turkey, 3D scans of Göbekli Tepe's 11,000-year-old pillars show carvings of constellations previously thought too faint for prehistoric recognition. These aren't just corrections to history books, they're full rewrites. One of the most jaw-dropping breakthroughs came in 2020 when researchers re-examined a cave wall in Spain's La Pasiega complex. What had been dismissed as abstract scratches for decades turned out to be a meticulous star map etched by Neanderthals over 40,000 years ago. The arrangement of dots matched the constellation Cygnus with 90% accuracy, suggesting these early humans didn't just notice the night sky, they studied it systematically. Suddenly, the timeline of astronomical knowledge stretches back far earlier than we ever imagined. Yet every discovery raises new questions. Why did cultures separated by continents align their monuments to the same stars? How did they achieve such precision without written language or modern tools? Some answers may lie in emerging technologies like archaeoacoustics, which studies how sound waves interact with ancient structures. At Peru's Chavín de Huántar, scientists found that certain star-aligned conduits amplify specific frequencies during equinoxes, hinting at rituals where architecture, astronomy, and sound converge. What's becoming undeniable is this: we've underestimated our ancestors. Their primitive tools were far more sophisticated than we assumed, their curiosity as relentless as any modern scientist. As Lydia reveals hidden causeways in the Amazon and AI decodes star lore in indigenous oral traditions, one truth comes into focus: we're not just uncovering lost knowledge. We're reclaiming a lineage of cosmic wonder that connects us all. Practical lessons from ancient astronomers. There's something humbling about realizing that the same stars our ancestors relied on for survival still hang above us. We've just forgotten how to see them. In a world where artificial light drowns out the Milky Way and notifications distract us from the moon's phases, those ancient skywatchers hold unexpected wisdom. Their greatest tool wasn't some advanced technology, it was patience. Imagine dedicating a lifetime to tracking a single planet's path, not with software, but with nothing more than your eyes and a stick in the dirt. That relentless focus turned chaos into patterns, randomness into meaning, but their genius didn't stop at observation. They wove science into the fabric of daily life in ways we've since abandoned. The Maori of New Zealand didn't just name the Pleiades Matariki, they timed their planting seasons by its rising. The Babylonians didn't merely record eclipses, they used them to refine their calendar, linking celestial events to harvests and festivals. For them, astronomy wasn't a separate discipline, it was inseparable from cooking, building, worshipping, even governing. What if we took a page from their playbook? You don't need an observatory to start. Simply stepping outside on a clear night and letting your eyes adjust can be a revelation. Ancient cultures thrived without light pollution. Their skies blazed with stars we now strain to see. Organizations like the International Dark Sky Association are fighting to reclaim that heritage, proving that we don't have to sacrifice progress to rediscover wonder. The deeper lesson here isn't just about stargazing, it's about perspective. Those early astronomers didn't see the universe as a cold, empty void. To them, meteors were messengers, comets were omens, and constellations were stories etched in light. While our science has grown more precise, we've lost some of that poetic connection. Maybe that's why their legacy endures. They remind us that curiosity isn't just about answering questions, but about learning which ones to ask. So tonight, if you catch yourself scrolling under artificial glow, consider stepping into the dark. Look up. You might not chart a new constellation or predict an eclipse, but you'll be part of a tradition as old as humanity itself. And in that shared sky, the past isn't really past. It's just waiting for us to notice. Some of the most persistent myths about ancient astronomy sound like they're pulled straight from a sci-fi novel: extraterrestrials aligning the pyramids, lost civilizations with impossible star maps, or secret alien knowledge encoded in temple walls. It's easy to see why these ideas capture imaginations. But here's the catch: when we credit otherworldly forces for humanity's early achievements, we do something far more damaging than spreading misinformation. We rob our ancestors of their rightful genius. Take the pyramids of Giza. The precision of their alignment with true north is often cited as proof they couldn't have been built without alien intervention. Yet archaeological evidence tells a different story. Workers' villages unearthed nearby reveal meticulous planning, copper tools, and ingenious techniques like using water-filled trenches as leveling guide. The Egyptians didn't need aliens, they had geometry, patience, and an intimate knowledge of the stars honed over generations. The same goes for claims about the Dogon people's supposed extraterrestrial knowledge of Sirius B. While their celestial lore is undeniably sophisticated, anthropologists point to plausible explanations: contact with Western missionaries in the early 20th century, or centuries of oral tradition refining observations of Sirius's brightness fluctuations. Neither scenario requires cosmic visitors, just human curiosity and dedication. What's fascinating isn't the myths themselves, but why they persist. There's a tendency to assume ancient cultures couldn't possibly match our modern understanding without outside help. This ignores the sheer depth of their ingenuity. The Mayans calculated Venus's cycles with near-perfect accuracy because they devoted lifetimes to tracking its movements, not because they inherited alien star charts. Polynesian navigators crossed oceans by memorizing wave patterns and star paths, skills taught through grueling apprenticeships, not extraterrestrial gifts. Dispelling these myths isn't about dismissing wonder, it's about redirecting it. The truth is far more inspiring. Ordinary humans, armed with nothing but observation and perseverance, decoded the cosmos long before telescopes or satellites. Their legacy isn't diminished by removing aliens from the equation, it's elevated. They weren't passive recipients of celestial secrets, they were active explorers pushing the limits of their world to touch the stars. So the next time you hear a sensational claim about ancient astronomy, ask yourself, is it more thrilling to imagine outside intervention or to recognize the brilliance of people who, with nothing but stone, sky, and relentless curiosity, mapped the heavens? The answer tells us less about them and more about how we view our own potential. There's something profoundly moving about standing where ancient astronomers once stood, tracing their gaze across the same constellations that guided their lives. You don't need a time machine to connect with their wisdom, you just need to step outside and look up. Whether you're witnessing the summer solstice sunrise at Stonehenge or watching the serpent of light slither down El Castillo at Chichen Itza during the equinox, these living monuments still perform their celestial dances just as they did millennia ago. It's one thing to read about ancient astronomy, it's another to stand in the footsteps of those who first mapped the heavens. If travel isn't possible, technology can bring the cosmos to your fingertips. Apps like Stellarium or Sky Safari let you rewind the night sky, showing exactly how Orion or the Pleiades appeared to Babylonian astrologers or Polynesian navigators. For a deeper dive, museums hold tangible echoes of these skywatchers' brilliance. The British Museum's Babylonian star tablets and the Beijing Planetarium's replicas of ancient Chinese armillary spheres aren't just artifacts, they're windows into how entire civilizations measured infinity. But some of the most profound lessons don't come from glass cases or glowing screens. They come from living traditions. Indigenous communities worldwide still carry ancestral star knowledge, from the Maori's Matariki celebrations to the Lakota's sacred star maps. Workshops led by elders or cultural centers often share these teachings, revealing how the sky isn't just a scientific canvas but a cultural compass. What's extraordinary is how accessible this legacy remains. You don't need a degree or expensive gear, just curiosity and a patch of dark sky. The same stars that told farmers when to plant, sailors where to sail, and priests when to pray still shine with those same stories. All we have to do is listen. At the heart of every ancient monument, every weathered star chart, lies something far more enduring than stone or bronze, an unbroken human impulse to make sense of the infinite. Those first astronomers didn't just study the sky, they wove it into their lives, turning celestial events into calendars, myths into navigational tools, and stone circles into cosmic classrooms. What's remarkable isn't just their accuracy, it's their audacity. With no technology beyond sticks and shadows, they dared to measure time itself by the tilt of sunlight on a temple wall or the slow dance of stars across generations. Today, as we marvel at Hubble's distant galaxies or James Webb's infrared revelations, it's easy to forget how much we owe to those early skywatchers. Our modern maps of the cosmos stand on foundations they laid: constellations named by Sumerian shepherds, solstice alignments carved by Neolithic farmers, planetary motions tracked by Babylonian scribes. Yet their legacy isn't just in the data they left behind. It's in the way they remind us that astronomy was never just about cold calculations. For them, the stars were alive, pulsing with stories, pulsing with purpose. So here's the invitation they extend across millennia, to look up with that same blend of wonder and vigilance. You don't need an observatory to continue their work. Sometimes the deepest connections happen in quiet moments, noticing how Orion rises earlier each winter, spotting Venus glowing low at dusk, or catching a meteor streak across the dark like a brushstroke from the past. The same cosmos that guided them still surrounds us, unchanged. Perhaps that's the most humbling truth of all. The gap between their world and ours isn't as wide as we think. They sought meaning in the stars just as we do. They measured, they dreamed, they dared to ask impossible questions. And in that shared curiosity, we're not so different after all. The night sky remains humanity's oldest heirloom, a gift, a guide, and a mirror reflecting our endless thirst to know what lies beyond. So tonight, step outside. Let your eyes adjust to the dark. However the sky appears to you, whether as a scientific frontier, a spiritual presence, or simply a backdrop to wonder, you're joining a chain of observers stretching back to the very dawn of thought. And who knows, you might just glimpse what they saw, not just points of light, but a story still being written.